Welcome guys, my name is Dr. Avitech, and in this video we're going to be treating the integrals of periodic functions. So it's very important as we're about to step into Fourier series properly. It's important that we know how to integrate some periodic functions, some basic periodic functions. Remember to hit the subscribe button, like this video, and share it across to your classmates. Now let us start. The first one is to integrate a constant. So the first one here is to integrate from minus pi to pi of dx. You know, dx is a constant. If you wish, you could just put a 1 here. It's a choice. If you put a 1 there. So when you integrate 1, you're just going to have x. And that's from minus pi to pi. So let's put in our limits. So anywhere I see x is going to be pi. And that's the upper limit. And then minus. For the lower limit, x will be minus pi. So put in a bracket for that one. So this will be pi. Minus is plus. So pi plus pi, that's 2 pi. So as you can see, that's when you integrate a constant. That's what you get when you integrate a constant. Number two, if you integrate from minus pi to pi of sine nx, what do we get? Now, why did we put in n? In case there's a number you want to place inside that inside this very function. So that's why the n is here. And we're going to learn about the n also when we step into Fourier series properly. So right now, if you should want to integrate this, first of all, let's differentiate nx. If you differentiate nx, you're going to have n, right? Differentiate nx with respect to x. You're going to get n. So this will become 1 over n. That's how we integrate trigonometric functions. So 1 over n times, integrate sine, you will get cosine. And then you get minus cosine. Then you put your angle, nx. And this is from minus pi to pi. Now what's common here is minus 1 over n. So this is minus 1 over n. Cosine of nx from minus pi to pi. Now the next thing I'm going to do is anywhere I see x, I'm going to be calling them pi. So this is minus 1 over n, open up a bracket. So this is the first one, upper limit. So this will be cos n pi minus lower limit cosine of n. Since s is minus pi, this will be n times minus pi. That's minus n pi. So this is minus 1 over n cosine of n pi minus cosine of n pi. Take note that cosine is an even function. You're going to learn about this in future problems. I'm going to make separate videos about even and odd functions. So cosine is an even function. So cosine, if the angle is negative or positive, it doesn't matter. So the negative part is same thing as the positive part. So minus n pi is same thing with when it's just n pi. That is why you notice that the minus here still remained, then this minus disappeared. Because the minus can disappear, cosine is even. So it can go away. So this is minus 1 over n times 0. Because cos n pi minus cos n pi is 0. So everything here is just 0. And that's just it. It's gone. Everything is just 0. Number 3. If you are to integrate from minus pi to pi of cos nx dx, what do we do for this one? Now what we're going to do is still the same. First of all, start with this nx. When you integrate nx, you have to differentiate first. When you differentiate nx, you're going to get n. So that's 1 over n. Then integrate cosine, you're going to have sine. And then you put the nx, and this is from minus pi to pi. So the next thing I'm going to do here is, this is 1 over n, open up brackets, sine n pi, the upper limit is pi. So this is n pi minus lower limit, this will be sine. Since I have nx and this is minus pi, n times minus pi is minus n pi. Okay. So this will equal to 1 over n. And then sine n pi plus sine n pi. Now, sine is an odd function. So for odd functions, the minus can come outside. This minus here will come outside. So the minus will come and means the minus here to become plus. But cosine does not behave like that. Sine is odd. That's why it's behaving like that. That's why this is plus. So this is 1 over n, and then sine n pi is 0. Sine n pi again. Okay, let me just first of all say sine n pi plus sine n pi is 2 sine n pi. So this is 1 over n, then 2 times 0. Now sine n pi is a special value. Anytime, any day, sine n pi is 0. Sine n pi is 0 anytime, any day. So sine pi, first of all, sine pi is 180. Sine 2 pi is 0. Sorry, sine pi, when I say sine pi, pi is 180. So sine 180 is 0. Sine 2 pi is 0. Sine 3 pi is 0. 4 pi will be 0, just like that. So it's always 0. So this is equal to what? 0. So that's for that one. Let's go to the fourth one. The integral from minus pi to pi of sine squared x, okay, sine squared nx dx. So what if for some reasons we have double? So that's why this is squared here. So what if for some reasons we have a square? How do we treat this? Okay, first of all, there should be a power reducing formula here. There's a way to reduce this sine to become something that the degree is now less. Now, the first thing I want you to know is, remember that when you were doing, what's it called? When you were doing trigonometry, you were told that sine squared s plus cos squared s is equal to 1, right? Okay. Also, you were also told that cosine of 2a is equal to sine squared a plus, no, that's a minus. Hold on. Cos 2a is equal cos squared a minus sine squared a. Aha. So I don't kind of mix this up. So this is actually from trigonometry. I'm coming from trigonometry. So this will be cos 2a equal to this cos squared a here. I think should I really derive this? This cos squared a here from this formula here is going to be 1 minus sine squared a. And then I'm going to put my minus sine squared a. So cos 2a is equal to 1 minus 2 sine squared a. Good. So let us make this sine, because this is our sine squared. This is our sine squared. This is our sine squared. This is from trigonometry. This is our sine squared. So I want to make the sine squared with the formula. So first of all, I could say, take this minus 2 to this side to make it positive. So this is 2 sine squared a equal to 1 minus. This one goes here, cos 2a. Now divide both sides by 2. So this is sine squared a equal to 1 minus cos 2a all over 2. And to make it nx, all of the a's will then change to nx. So that means this thing you see here is the integral from minus pi to pi, and that will then become 1 minus cos nx over 2 dx. Yeah, that's what it's going to be. And it's still the same. It's still the same. So this is from trigonometry, please. Every single thing here is from trigonometry. I didn't actually want to derive it, but I just wanted to show just a little working on how I got that. So right now, let us now integrate. Let us now integrate. There are different ways to do this. There are different ways to do this. But let us now integrate. So first of all, this half here, the half over 2, the over 2 is like a constant. So this is half integral from minus pi to pi. The what will be remaining is 1 minus cos nx dx. Yeah. So this is 1 over 2. Then let me open this guy up. Integrate 1. What would you have? You're going to have x. This thing has a 2 here. I said that something is not right. It has a 2. So this is 2nx. That's a 2. 2nx. Yeah, sorry about that. It has a 2. So it's supposed to be 2a. Remember I said all the a will change to nx, so that's 2nx. So when you integrate 1, you're just going to have x. And then minus, when you integrate cosine of 2nx, what would we then get? Hold on. I want to do something briefly. Let me see. There's something I want to do. I want to solve this much more faster, please. I don't want this video to be very long. Okay, let's see. So this, everything here, this is half. Let me kind of expand this integral. So I'm going to take the integral of 1. So integral from minus pi to pi of 1 dx minus the integral of, okay, from minus pi to pi of cosine of 2nx dx. Yeah, I can just do it like this to make life easy for me. So this is 1 over 2. We've earlier done this one, right? This is it here. And it's 2 pi. Good. 2 pi minus. Do you know that we've actually done this? This is it, right? So our n is 2n. It's the same actually. These two things are the same. But the n here became 2n in this case. So anywhere you see n, you're going to put 2. But the sad thing is, this location was the last location that n ended. So I would have put 2n here times whatever answer we had here. But the answer we had here was 0. And even if I put the 2n here, this will still be 0. So this integral will give me 0. You don't need to stress yourself about that. It's going to give you 0. Okay, so this is half times 2 pi. So 2 we cancel out 2. So that's pi. Yeah, I just want to do this the shorter way. Okay, number 5. For number 5, the integral from minus pi to pi of cos squared nx dx. So we have minus pi to pi. Now, for us to change this cos squared nx, the same way we did this one, cos squared a is equal 1 plus cos 2a all over 2. This one I don't want to derive it, but it's still based on this same derivation. Cos squared a is 1 plus cos 2a over 2. So that means I'm going to be having 1 plus cos 2nx, because in this case we don't have an a here. All we have is nx. We don't have an a. So anywhere we see a, we're going to put nx. Then divided by 2 dx. I think some people are making this outside. So let this half come outside. So this will be half. Then we're going to have the integral from minus pi to pi of 1 plus cos 2nx dx. Okay. Yep. So this is half. And then this very value we have here, let me expand the integral. So this is the integral from minus pi to pi of 1 dx plus the integral from minus pi to pi of cos 2nx dx. So this is half. Now if you integrate 1, what would you get? You get 2 pi. That's 2 pi plus this is still 0. We've done that before, right? It's still going to be 0. So this is half times 2 pi. When 2 cancels out, so you're going to be having your pi. So you see that, right? Beautiful. Now number 6 is a special type. The integral from minus pi to pi of cos nx cos mx dx. Now take note, please. I want to make this thing very short. I want to make it very short, please. Now if you look at this, this is nx. I think let me put the m first. Let me put m first. Let me put n second. So these two things, if you should integrate this, you basically get 0 at almost every point. You would always get 0 at almost every point. Apart from a particular point where the m and the n are not having the same numbers. Please take note. When the m, because m and n are numbers, if m and n remain the same, there's going to be an answer. But if m and n remain different, if they are different, you're going to be having what? 0. So when m, so it's equal to 0 when m is not equal to n. That's when it's equal to what? It's equal to what? 0. When these two things are different. Then it's equal to 1 when m is equal to n. Now, why do you think it's equal to 1 when m and n are the same? Look at this. If these two values are the same, that means you're going to be having cos squared, because this means a value that is the same is times another value. So that's square of it. Because when you say k times k, that's k squared. So when cos times cos, now become cos squared. And when we did cos squared, what did we get? We had, oh, sorry, this is supposed to be pi, not 1. So it's going to become what? It's going to become pi. You see that, right? So this is what we're going to be having. When these two are now the same, it's just like saying cos squared. And when we did cos squared, it was pi that we had. So that's why this will be pi. Also, similarly, the integral from minus pi to pi, when it's sine mx and sine nx dx. This will be 0 when m is not equal to n, and this will be pi when m is equal to n. So the 0 part is not always taken into consideration. So it's gone. So it is pi. If these two are the same, sine times sine is sine squared. And when we did sine squared, we had pi. So it's going to become pi. So that's actually very, very self-explanatory. I just want to skip all of this. 8. The integral from minus pi to pi of sine mx cos nx dx and the integral from minus pi to pi of cos mx sine nx with respect to x, these two guys are equal to 0. Always 0. Whether m is equal to no or n is equal to mo, they're always going to be 0. Now, it's just like saying that I think we can do, you do this from a graph. Integration evaluates area. Yeah, it evaluates area. So the area of these two guys, they would always cancel out. Every single part would always cancel out. So there's always a cancellation of areas here. So this would always be 0. So I don't want to stress myself to do with that. Let us go to the next one. And that is where we're going to start Fourier series properly. So in the next video, I'm going to explain Fourier series. I'm going to see you in that very video. Remember to hit the subscribe button, like this video, and share it across to your classmates. Bye.